Hello good viewers, welcome back once again. Today we have a nice looking equation, and guess what, this is a transcendental equation. We have 5 to the power of x plus x equals 7. We're going to solve for x. In this video I will be making use of the Lambert W function, so you have to stay tuned so that you will understand how to make use of this function. Now we need to take note that the Lambert W function with the following argument: x times e to the power of x simplifies to x, right? Now this is our main key. To solve this problem, this will be very important. Now let's see how we're going to solve this problem. We have here 5 to the power of x plus x, this is equal to 7. Now I'm going to change the sides of this equation, but that will not affect anything, and that will not affect the equation. So from the right we have 7 is equal to 5 to the power of x plus x. Now from here we're going to subtract x from both sides. So if you subtract x, we have here 7 minus x, this is equal to 5 raised to the power of x plus x minus x, and that will be 0. Right? So what do we do next? From here we're going to divide both sides by 5 to the power of x. So here we have 7 minus x divided by 5 to the power of x. This will be equal to 5 to the power of x divided by 5 to the power of x. Now from here we all know from the right this will divide to 1, right? So from here let us take note of the following. When we have 1 all over a to the power of n, this can be written as a to the power of negative n, right? So from here, remember this is same as 7 minus x times 1 over 5 to the power of x. So we can write this as 7 minus x times 5 raised to the power of negative x. And from the right, we have 1. Okay, so what do we do next from here? From this here, we have 7 minus x. So how do we make the power of 5 here to be exactly the coefficient? So how do we achieve this goal? So now the next thing we're going to take note of is that when we have a to the power of m and we're multiplying by a to the power of n, remember we have the same base, right? So this will become a to the power of m plus n, right? So this is actually telling us that there's something we need to multiply to both sides, but the base must be 5. So that when we add the powers, the power of 5 here will be exactly the coefficient of 5 here. That is the 5 to the raised power of negative x. So let's think about multiplying both sides by 5 to the power of 7, right? And let's go ahead and do that. So from the left we have 7 minus x times 5 to the power of negative x, and here we're multiplying by 5 to the power of 7. This will be equal to 1 times 5 to the power of 7. Okay, so from here, remember this power, we have the same base. With this property here, we can add the powers. That will be negative x plus 7, which is same as 7 minus x. I think we have achieved the goal, because here we have 7 minus x, right? So here this becomes 7 minus x, then multiply by 5 raised to the power of 7 minus x. Then from the right, this is equal to 5 to the power of 7. Okay, now let's think about this property. M is the same as e to the power of natural log of m, right? What if m has power? Let's say m has power of b. Then this will be e to the power of b multiplied by the natural log of m, right? So from here, 5 to the power of 7 minus x, we can write it in exponential form, right? So from here we have 7 minus x, then multiplied by e, raised to the power of 5 there, 7 minus x times the natural log of the base, which is 5. Then this is equal to 5 to the power of 7. Now, before we be making use of the Lambert W function, remember that the power of e here must be equal with the coefficient. But here we have 7 minus x only, but from the power here we have 7 minus x times natural log of 5. So the idea now is to multiply both sides by the natural log of 5. So from here, we have 7 minus x multiplied by the natural log of 5 times e raised to the power of 7 minus x multiplied by the natural log of 5. This will be equal to 5 to the power of 7 multiplied by the natural log of 5. So from here, we're going to make use of the Lambert W function, right? From both sides. Oh, no space here. So actually, that is the Lambert W function from here, right? And with the property, remember, this will simplify to 7 minus x times the natural log of 5, right? So that will be 7 minus x times the natural log of 5. This is equal to the Lambert W function of 5 to the power of 7 times the natural log of 5. So from here, let's divide both sides by the natural log of 5, right? Remember, we're solving for x. So here, by the natural log of 5. So from here, this will cancel this. So we're left with 7 minus x from the left-hand side. This will be equal to the Lambert W function of 5 to the power of 7 times the natural log of 5 all over the natural log of 5. Okay, so from here, we're going to solve for x, and from here, x will be equal to 7 minus the Lambert W function of 5 to the power of 7 times the natural log of 5 divided by the natural log of 5. Now, most of us that doesn't like making use of this formula, this function I mean, is because of the kind of machines or calculators that can compute these values, right? But do not be surprised that I myself, I have a calculator, just a calculator that can give you the value of this Lambert W function operating on numbers. So if you wish to have this calculator, please, I want to see your comments, because I will give you the link so that you will download this calculator as well. It's just a calculator and it has many different special functions. Okay, now when I use my calculator to approximate this, I found out that this is approximately equal to 1.102569271, and this is the right answer. Thank you for watching. Please support my channel by sending me a super thank. You can subscribe, and please do not forget to turn on the notification button so that you'll be notified anytime I upload new video. Thank you for watching. Bye bye. See you in my next video.